All right, Unit 1, Lesson 2, we're going to look at graphing equations. We're going to look at finding x and y intercepts, lines of symmetry, determine if it has symmetry, and so on. You guys can read it. Let's go down here and look at example 1. What do you notice here? What type of graph do I have? This is a review. It's an x squared. It's a parabola. Quadratic function. What does that negative in front of the x squared do? Flips it upside down, and then that 1 does what? Moves it up 1. So where is the vertex of this graph going to be? 0, 1. And if you remember, this is what the parent graph looks like. So that parent graph gets flipped upside down and moved up 1. So instead of going over 1, up 1, from this point we're going to go over 1, down 1, and over 2, down 4. Questions on that? You could have, if you don't remember that, you could make a T-chart. Make sure when you do T-charts, you do positive and negative numbers. So you get 1 minus negative 2 squared, which is 1 minus 4, which is negative 3. At negative 2, did I go down 3? Sure did. All right? So you can make T-charts if you don't remember the flipping and all that good stuff. Questions there? Intercepts. Remember, when you need to find the x-axis, the x-intercept, you let y be 0. So to find the x-intercept, let y be 0 and solve for x. To find the y-intercept, you let x be 0 and solve for y. So example 2, find the intercepts. So for the x-intercept, what do? Let y be 0. So we get 0 equals negative x squared minus 5x. How do I solve this problem? Do what? Factor out a negative x. It's an x squared function, so we have to factor. They both have a negative x in common. So that gives me x plus 5. Set each of them equal to 0. So we get an x-intercept of 0 and an x-intercept of negative 5. So that's 0, 0, 0, negative 5, 0. For y-intercept, we let x be 0. Those are usually our easier ones to do. 0 minus 0, we get a y-intercept of 0. That's 0, 0. Questions here? Everyone done? All right, let's look at symmetry then. A graph is symmetric with respect to the y-axis if whenever the point x1 is on the graph, then the point negative xy is also on the graph. If replacing x with negative x results in an equivalent equation, then the graph is symmetric with the y-axis. An example, if this is 1, 2, this one over here is negative 1, 2. As you can see, the y values didn't change. The x values are opposite. If I fold along the y-axis, it's going to match up, so I have symmetry with respect to the y. Have symmetry with respect to the x, that's going to be x negative y. This says if replacing y with the negative y results in an equivalent equation, then we have symmetry with respect to the x-axis. An example of that would look like this. If this was 2, 3, then this one here would be 2, negative 3. You can see that if you fold among the x-axis, the graph's going to fall on top of each other, and you can see the x's didn't change, but the y's did. If we have symmetry with respect to the origin, then they're both going to change. An example of this would be the y cubed graph, or y equals x cubed graph. This is 1, 1. This one here is negative 1, negative 1. Has symmetry with respect to the x-axis. In this one, we replace both the x and the y with a negative value, and we look to see if we have symmetry with the origin. Questions there? All right, I have 3 examples, and what I'm going to do is I'm going to make a chart here. So we're going to look for symmetry with respect to the x-axis, the y-axis, sorry, we'll do y first. X-axis, origin. And then for the x-axis, I'm going to put in a negative x. For y, if I have symmetry with respect to the y-axis, symmetry with respect to the x-axis, I let y be negative. And then symmetry with respect to the origin, I let them both be negative, and I look to see if I come up with the original equation. So for A, where I see x, I'm going to put a negative x. Well, what is a negative x squared? It's the same as x squared. Do I have the same graph as equations what I started with?
Yeah.
Yes. So this one has symmetry with the y-axis. Let's go ahead and check for the x-axis. Where I see y, I'm going to put a negative y. You need to be careful here. When I multiply both sides by a negative 1, this becomes a positive y. When you multiply by negative 1 and you're dealing with fractions, you only multiply either the top or the bottom by a negative, not both. I'm going to multiply the top by negative, leave the bottom one alone. You multiply top and bottom, it's like multiplying by a positive 1. Is this the same as the original? No. So we have no symmetry here. Then for the origin, I plug both in. What do you think is going to happen here? Are we going to come up with the original one? Now, when I square that denominator, I'm right back to this problem here. So this is like multiplying by negative 1. So I get negative 1 over x squared plus 1. So we have no symmetry here. Okay, let's look at B. Plug in a negative x. So I get a negative x cubed minus a negative x. So this gives us, when I cube a negative, what happens? It becomes a negative. Subtract a negative, we get a positive. So are these two the same? No. Symmetry with respect to the x-axis, I put a negative in for y. I've got to multiply both sides by negative 1. Is this the same as the original function? No. Now I'm going to plug in a negative for both. So the right side is negative x cubed plus x. Then when I divide by a negative 1 or multiply everything by a negative 1, we get y equals x cubed minus x. Is that my original? Yes. So I have symmetry here. And for the last one, negative x times y equals 4. That gives us xy equals negative 4. Is that the same? And then x times negative y. Again, that's xy equals negative 4. It's not the same. And then I let both of them be a negative. What happens here? We get positive xy equals 4. Is that our original? So we have symmetry here. questions?